These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. Thank you. Well, let's start by seeing whether we can predict the products for this reaction. This is a reaction that we've seen before. This wasn't a chapter 19, this reaction. This was from earlier when we were studying aldehydes and ketones. Okay. So let's see if we can predict what would happen here. Does this ring any bells? Do you have any ideas about what's going to happen here in general?
That we're going to get a coordination of the carbonyl oxygen, and then a nucleophilic attack of the carbonyl carbon with the amine.
So, and then overall, what type of product do you think we're going to get?
We're going to get I'm not quite sure.
Okay. Now we are attacking, what type of functional group is this?
It's a ketone.
That's right. And what type of functional group is this?
Enamine.
That's right. So we're going to have a nucleophilic attack on an aldehyde or a ketone. And we know that those fall into those four categories that we've seen before. And we have to decide which of the four categories we're going to be in here. Now, this is what we would call, well, what type of amine is this?
Acidic.
That's right. Primary, secondary, or tertiary?
It is secondary.
That's right, because this nitrogen is attached to two carbon chains. Now, we actually saw that secondary amines go through a different category of attack than primary amines. I don't know if you remember that. Do you remember what type of category of attack we would have for secondary amines?
Category 3.
That would be for primary amines. And these actually go through category 4, which we didn't talk about very much. It looks like maybe you didn't get a chance to, I mentioned one other video on enamines. Maybe
it was the one that was below the suggested one. Yeah, I didn't watch that.
Okay, well, we'll have to review that now. Okay, so we talked about this briefly for aldehydes and ketones, and now we'll need to review this. This was a category 4. Okay. Do you have your handout for aldehydes and ketones? So let's look at page 1 of that aldehyde and ketone handout. And we're looking at category 4. That's the category we've talked about the least.
Okay.
But notice what happens in category 4 is that the nucleophilic atom only attacks once. But the asterisk carbon also gets attacked by the beta carbon, or by the alpha carbon, the carbon that's connected to it. So if you look at that category 4, we've talked about how helpful it is to asterisk the carbonyl carbon and the carbonyl oxygen. So in category 4, not only is the nucleophile going to attack the carbonyl carbon, but this alpha carbon is also going to attack the carbonyl carbon and form a double bond.
Okay.
That's the general approach that we're going to have here. And then the mechanism for that, let's see if we can find the mechanism. It's not on page 1. You want to look for the page with the category 4 reactions. Not on page 2. There we go. So that has our basic mechanism. Now notice that there's only one type of nucleophile here on page 3 that goes to this category 4, which is the secondary amine, which is exactly what we have on the board here. This reaction can work under acid or base catalyst, but you'd only be expected to know the mechanism probably for acid catalyst. So that's the only thing that's in the notes there. Well, let's go through that mechanism. So, well, let's just start trying to draw that mechanism out here. So let's draw what do you think would happen first with these reagents. And of course, if you get stuck, you can check the handout, because that gives the whole mechanism. Yeah, nitrogen still has that hydrogen on it. That's one of the trickiest parts right there, just getting the right product. One thing, again, that really helps me here is continuing to put in the asterisks. And now we simply have to show up here the nucleophilic nitrogen that's attached, and it's still attached to everything it was attached to in this picture. 1, 2, 3, 4, 5. Good. Okay. Now remember, well, now is this one of the categories where the carbonyl oxygen is going to stay or where the carbonyl oxygen is going to leave? If we go back to page 1, is the carbonyl oxygen here going to be staying or leaving since this is category 4?
It's going to be leaving.
That's right.
Okay.
Well, based on the conditions that we have so far, can this carbonyl oxygen leave right now?
No.
Let's see, why not? I guess if it left, it would have to have a negative charge. But that's not consistent with acidic conditions. In acidic conditions, everything has to be positive or neutral. So we have to do something to prepare this leaving group before it can leave. What can we do to make this into a better leaving group?
Could we have it take the hydrogen from the nucleophile?
That's right. This nitrogen wants to get rid of its hydrogen anyway.
Yeah.
So that would be, we can kill 2 birds with 1 stone and have the oxygen take that proton. Let's also consult our handout for a second to see how that could help us here. So we did our, so let's see, we're in the left-hand column of page 3 on the, let's see, so the carbonyl oxygen gained a proton, the nucleophilic nitrogen attacked the carbonyl carbon, and then the nucleophilic atom has to lose a proton and the carbonyl oxygen has to gain a proton. And the asterisk here indicates that you can combine those into one step, which is what we just did here. We combined the nucleophilic nitrogen losing the proton and the carbonyl oxygen gaining the proton.
Okay.
So you could also just consult the handout to see what step you need to do at this point, which is move those protons across. Okay. It probably would be more realistic to show this as 2 separate steps. First the nitrogen losing the proton, and then the oxygen gaining a proton, but it's an acceptable shortcut to save some time and show the oxygen is taking it directly. Going back to this picture, we have to make sure that we're changing 2 charges at the initial tail and the final head. Well, careful, what I meant was the charges in this picture are fine, but you have to show 2 charges that are changing in the new picture over here. After all, who's at the final head? This oxygen. That's why the oxygen went from positive to neutral, because it was gaining electrons.
Okay.
But who was at the initial tail of this arrow?
The carbon.
Right. That doesn't mean we put a positive charge on this picture. It means we put the positive charge on the picture after it's lost the electrons. That way we still have a net charge of +1 overall.
I see.
That was really the whole point of the water leaving, to make room for somebody else to attack this carbonyl carbon. If there's no room over here, then no one else can attack this carbonyl carbon. Good. I think you got that last step right.